everybody. Today we're going to be talking about another way to solve systems of equations. So in my last video, we talked about how to solve systems of equations by graphing. Today we're going to talk about how to use substitution to solve systems of equations. Remember in the last video, we learned that a system of equation is two or more equations that are graphed in the same coordinate plane. Today we're going to just be looking at another way to get other more exact answers than we can maybe get by graphing. There's a few notes that we need to know before we start solving systems of equations by substitution. We need to start by ensuring that at least one of the equations is set equal to x or y, and that may mean that we have to solve for x or y before we can substitute. Once we have done that, we need to substitute whatever is equal to x or y into the other equation. After that point, we will solve for x and y and then use that value to solve for the other variable. We're going to look at 4 different examples of how this works. So let's get started. Here's our first example. X equals 3y minus 9 and 5x minus 2y equals 7. Well, we need to start by ensuring that at least one of the equations is set equal to x or y. This first equation is set equal to x, so we're ready to go. We're going to take what's equal to x, 3y minus 9, and substitute it in for the x in the other equation. So now, instead of x in the other equation, we have 3y minus 9. Now we're going to solve for y. So we'll distribute this 5, which gives us 15y minus 45 minus 2y equals 7. We'll now combine like terms, so 15y minus 2y is 13y. Now we can add 45 to both sides of our equation. That gives us 13y equals 52. Dividing by 13, y equals 4. So now we have our y value, but we need to find our x value. So we're going to take this y value and we're going to substitute it into either of the equations that we originally had. I'm going to substitute it into this first equation because it looks a little easier to solve. Let's zoom out so we can see the whole thing. So I'm going to take this 4 that I just solved for and substitute it back into the y in this first equation. So x equals 3 times 4 minus 9. 3 times 4 is 12 minus 9. 12 minus 9 is 3, so x equals 3. That means that my solution is 3, 4. The point 3, 4 will be where these two lines intersect. It is the coordinate that these two equations have in common. Next up, we have x plus y equals negative 5 and 4x minus 5y equals negative 20. Well, neither of these are set equal to x or y, so we're going to actually solve this first equation. We're solving it for x, and we're going to do that by subtracting y from both sides of the equal sign. We could also solve it for y. Either way would work. It just changes your math a little bit, but you'll get the exact same result. So now x is equal to negative y minus 5. So I am going to substitute that expression, negative y minus 5, in for the x in my second equation. That leaves me with 4 times negative y minus 5 minus 5y equals negative 20. So 4 times negative y minus 5, which again we substituted for x, when I distribute is negative 4y minus 20 minus 5y equals negative 20. We can combine like terms. Negative 4y minus 5y is negative 9y minus 20 equals negative 20. We'll add 20 to both sides. That leaves me with negative 9y equals 0. I can then divide both sides by negative 9, so y equals 0. Now that I've solved for my first value, which is y equals 0, I'm going to substitute it back into any of these 3 equations at the top. All of them will work to get me my final solution. So I'm going to substitute it. I chose to substitute it into this equation, x equals negative y minus 5, which means x equals negative 0 minus 5. Well, negative 0 is 0, minus 5 is negative 5. So my final solution to this entire example is negative 5, 0. That is the coordinate that both of these equations have in common. That is the solution. Let's look at two final examples. Here we have negative 6x plus 3y equals negative 12, and y equals 2x minus 4. Well, 2x minus 4 is set equal to y. So I'm going to take this expression, 2x minus 4, and substitute it in for the y in the first equation. That gives me negative 6x plus 3 times 2x minus 4 equals negative 12. Well, 2x minus 4 is the same as y, which is why I was allowed to substitute it in. I'm going to go ahead and distribute. So negative 6x plus 6x minus 12 equals negative 12. Now I'll combine like terms. Negative 6x plus 6x is 0 x's, so those cancel out, and I'm left with negative 12 equals negative 12. Well, negative 12 equals negative 12 is a true statement, and I have no more variables there anymore. And we remember from our equations unit that if we cancel out all of our variables and are left with a true statement, we will have infinitely many solutions. So this is the same as when we solve systems of equations by graphing and our lines were on top of each other. These are actually the same line, and every single point will be a point that these two lines have in common. Okay, for our last example, we have y equals 2x plus 5 and y equals 2x minus 5. Well, both of these equations are set equal to y, so it doesn't matter which one I choose, but I'm going to take this first equation, y equals 2x plus 5, and I'm going to take the expression 2x plus 5 that's equal to y and substitute it in for this y. So I have 2x minus 5 equals 2x plus 5. These are both equal to y. And I'm going to subtract 2x from both sides of my equation, and that leaves me with negative 5 equals 5. Again, we remember from our equations unit that if an equation results in a false statement, there is no solution. So in this video, we learned how to solve systems of equations using substitution. We learned that you need to start by making sure one of the equations is set equal to x or y. You need to substitute what is equal to x or y into the other equation, and then solve for the other variable. When the equation results in a true statement, there are infinitely many solutions. When the equation results in a false statement, there are no solutions. Thanks for watching this video. I hope it was helpful. Make sure to subscribe if you're in my class so you never miss a video, and I'll see you next time.